AMCA, Advanced Medium Combat Aircraft, is one of those projects of HAL which is developing at a very rapid pace, something which is unusual of the government office nature of HAL. Due credit goes to Aeronautical Development Agency, ADA, and Aircraft Research and Design Center, ARDC, who are developing the aircraft. Before answering the question, please have a look at the timelines. The project started in 2010. Project definition commenced from February 2013 and ended on March 2014. The project was put on hold for some time as ADA was focusing on the IOC of LC-8 Aegis. The Engineering Technology and Manufacturing Development (ETMD) phase started in 2014. The conceptualization was done till 2015 when the general design was frozen after extensive wind tunnel testing. Project entered detailed design phase (DDP) on February 2019. The first prototype is reported to be unveiled by 2024 and the first flight is scheduled in 2025. Since HAL gained a lot of experience from delays with LC-8 Aegis, the AMCA is being developed with a constant feedback from the EAF to eliminate rework and delays. The project is off track by only few years as of today and still in good timelines. Some of the recent developments with respect to the AMCA available in the public domain are DSI, Diverterless Supersonic Inlet. A diverterless supersonic inlet, DSI, is a type of jet engine air intake used to control airflow into their engines. It consists of a bump and a forward-swept inlet cowl, which work together to divert boundary layer airflow away from the aircraft's engine. This eliminates the need for a splitter plate, while compressing the air to slow it down from supersonic to subsonic speeds. This helps to reduce weight by as much as 300 kilograms. The air inlet ducts are in DSI configuration. DSI air intakes have a bulge near the inlet to divert the boundary layer of the air entering the engine just like in a F-35. A diverterless supersonic inlet, DSI, is a type of jet engine air intake used to control airflow into their engines. It consists of a bump and a forward-swept inlet cowl, which work together to divert boundary layer airflow away from the aircraft's engine. This eliminates the need for a splitter plate, while compressing the air to slow it down from supersonic to subsonic speeds. This helps to reduce weight by as much as 300 kilograms. The air inlet ducts are in DSI configuration. DSI air intakes have a bulge near the inlet to divert the boundary layer of the air entering the engine just like in a F-35. S configuration air intake. The airflow configuration of the air intakes are going to be serpentine configuration. This means the air will flow in an S configuration and the compressor blades will not be visible from the front. This reduces frontal radar cross-section, RCS, and aids stealth. The control surfaces will be controlled by fly-by optics instead of fly-by-wire. It makes use of optical fiber instead of electrical wires and the signals are in the form of light instead of electricity. It is faster and immune to any kind of electromagnetic hindrance. This digital fly-by optics system is based on the next generation digital flight control computer. It will have quadruple redundancy, 4 different computing channels with independent power supply. It'll have a gallium nitride-based SR radar which consumes lesser power but provides higher range and tracking ability. The present SR radars are gallium arsenide-based. Possibly this will be the indigenous UTM radar. The cockpit will have just one single wide touch-enabled multifunctional display just like in F-35. The first batch of AMCA will use the General Electric F414 AP engines capable of producing 116 kilonewtons of thrust. It'll have super cruise capability. This is an improved version of the same engine used in the F-A-18 Super Hornet. The South Korean stealth fighter project called KFX also uses 2 GE F414 engines to power. The second batch of AMCA will use indigenous engine built in JV with Rolls-Royce. The maximum speed will be limited Mach 1.8. Service ceiling will be 50,000 feet and G limit will be +8/3.5. The planned design empty weight will be 12,000 kilograms, loaded weight of 20,000 kilograms and the external weapon carrying capability of 5,000 to 6,500 kilograms. It'll have an IRSD sensor but the positioning is not declared yet. It can be placed below the nose like in F-35, but this configuration is not very good. The best place is above the nose in front of the cockpit, but it reduces the stealth characteristics. It'll have a next-generation network-centric aircraft management system developed by a DRDO lab, Defense Electronics Application Laboratory, DEAL. It'll have seamless data fusion, cooperative engagement capability. That means multiple aircraft will be able to operate in a perfect synergy. Missile launch aircraft can be different from the one guiding the missile at different points. Structure: wing is diamond-shaped trapezoidal wing, similar to F-22 Raptor and F-35 Lightning II. The tail wing is an all-moving fuselage-mounted stabilator like the one in Su-30 AMCA. The vertical stabilizer is in V configuration, like the FA-18, F-22 or F-35, and unlike J-20 is not all-moving. There will be no air brake and the control surfaces will act as air brakes. There will be internal weapons bay which will be able to carry air-to-air and air-to-ground weapons. The internal bays will also be able to carry fuel tanks. This reduces the US as well as improves the aerodynamic performance. The fuselage will be composite just like the Tejas and will have a coating of radar-absorbent materials. WAME Technologies Private Limited from Hyderabad being tasked to develop a 1:1 scale model of the AMCA for ARS testing along with a ground testing aircraft for stress and vibration tests. It is also reported that the production of AMCA will be in a public-private partnership and one of the companies from Tata Advanced Systems or L&T Defense will be the partners with HAL to produce the AMCA at a high rate of production. Quite possible that all the parts will be built by a private company and HAL will act as a lead integrator. Also, we cannot rule out the possibility that the private company will take the complete ownership of production. Text courtesy, Subhadeep Paul.